Hi, I'm Max. In this video, we are going to talk about differentiation. Actually, these are the basics of differentiation. What is differentiation? Why we need differentiation? Okay, let me explain it. Consider any 2 points, A and B, on any curve. The line joining A and B is called a chord. The line that touch the curve at A is called the tangent at A. The line perpendicular to the tangent at A is called the normal at A. So, these things can be used to find the gradient of a tangent to a curve. But, if the tangent is just drawn by eye, the value obtained can only be an approximation. So we need more precise method for determining the gradient of a curve, whose equation is known. Let us consider the problem of finding the gradient of the tangent at a point A on a curve. If B is another point on the curve, fairly close to A, then the gradient of the chord A, B, given an approximate value for the gradient of the tangent at A. As B gets near to A, the chord A, B, gets closer to the tangent at A, so the approximation becomes more accurate. So as B gets closer and closer to A, we can say the gradient of chord A, B, gets closer and closer to the gradient of the tangent at A. This fact can also be expressed in this form. Limit B close to A, the gradient of chord A, B, is equal to the gradient of tangent at A. Okay, let's get a general point, A, and a variable small change in the value of x between A and B. A new symbol, delta, is used to denote this small change. When delta appears as a prefix to any letter representing a variable quantity, it denotes a small increase in that quantity. Let's get some examples. Delta x means a small increase in x. Delta y means a small increase in y. Delta t means a small increase in t. There is something specially you should note. That is, delta is only a prefix. It does not have an independent value, and cannot be treated as a factor. Let's consider the gradient of the curve with equation y equals x squared. This time, we will look for the gradient at any point A on the curve, and use a point B, where the x-coordinate of B is x plus delta x. For any point on the curve, y equals x squared. So, at B, we can get the y-coordinate like this. Therefore, the gradient of chord A, B, which is given by increase in y, divided by increase in x, like this. Now, as B is getting close to A, delta x close to 0, therefore, we can get the gradient of curve at A, like this. Now we can get gradient at any point on this curve. We just only need the x-coordinates. Look at the examples. At point where x is equals to 3, the gradient is 6. Likewise, if a point at x equals 4, and y equals 16, the gradient at this point is 8. The process of finding a general expression for the gradient of a curve at any point is known as differentiation. The general gradient expression for a curve is itself a function. So, it is called the gradient function. For an example, for the curve y equals x squared, the gradient function is 2x. See, the gradient function is derived from the given function. It is more often called the derived function, or the derivative. Okay, look at this example question. Pause the video, and try to do this. Okay, let A and B as 2 neighboring points on the curve, like this. These are the y-coordinates of A and B. Then you know how to find the gradient of the chord A, B, and simplifies it. If B is close to A, then we know delta x is close to 0, so find the limits. Then you can obtain the gradient function of the given curve. Then, you can find gradient at any point on the curve. You just need to add x values to the gradient function. Okay, that's how to solve this kind of questions. I put some exercise for you, the link in the description. In this stage, try to do the exercise 1. Okay, let's learn the notation. We have seen that differentiating x squared gives 2x. One way to write this fact, dy by dx equals 2x. Let's see some examples. Don't worry about the answers. If you don't know how to find them, I will teach you, step by step later. At this time, just look at how to show the derivative with respect to x of y. Note carefully that d has no independent meaning, and must never be regarded as a factor. So, dy by dx means the derivative with respect to x of y, like this. There is an alternative notation. Concentrates on the function of x, rather than the equation of the curve. For an example, y equals f(x). If the y equals x squared, then we can say f(x) equals x squared. We can denote dy by dx as f(x). Then we know f(x) is equals to 2x. In this form, f' means the gradient function, or the derived function. Either of these notation can be used for variables other than x. Let's look at this example. If we differentiate y with respect to z, we can write like this. Similarly, we can differentiate s with respect to t. Okay, that's all for now, but this is not the end of Differentiation Basic lesson. I will continue the lesson in my next video. I was rushing, because I didn't want to make this video too lengthy. But, unfortunately, I had to divide this lesson into 2 parts. If anyone hard to understand, I recommend you to turn on subtitle, and pause the video, and rewind. After that, try to catch what I'm saying. And, another thing, I need to tell you that I will put all the exercise and the answers in my drive. So download the exercise and try to practice. Thank you for watching this. Please give me a feedback about this video. Then I can improve my video quality. See you later. Bye.